Okay, we are on to the soldering part, or prep work for the electronics. This involves a lot of solder work and a lot of practice to do this stuff. Now, everybody in the hobby that has done this has heard and seen the videos. Oh, crank up your heat, crank up your heat. You know, to do various things in the hobby, like connecting motor wires or power leads for XT60s and all that stuff. And you really shouldn't do that. This is especially on flight controllers and ESCs and stuff. These are sensitive electronics we're working with. You do not want to overheat them. So you want to keep your iron just barely enough to melt your solder. And we're going to prep the tip here for mine. Now this is just iron just heated up, so you want to get a couple good balls of solder on your tip to clean it off and get it nice and shiny and silver all the way around. Not only is it better for doing your solder work, but it's also good for maintaining your gear. Now, a little tip for you guys. Everybody says, you know, well, that's wasting solder. But here's the thing. If you take all those little solder balls after you're done soldering and you save them in a jar or a case or something, later on you can melt them all together to custom make your lead weights for your aircraft when you try to balance things like the FT foam board planes and all that stuff. So, alright, on to soldering. Like I said, the iron that I got is an AOU 469. I've got it set between 3 and 4, which is the happy place for soldering little stuff like this. And one of the mistakes everybody makes is they heat the pad up, then feed their solder in. That's bad for two different reasons. One, you're heating the crap out of your board unnecessarily. Two, as you feed that solder in, especially on bigger pads like these, you tend to make a lot of spatter. Little balls of solder go flying all over these little tiny areas where it can short things out. Not good, guys. So what you do is put a tiny ball on the tip, very tip of your iron, and once you do that, you place your solder on the pad you're going to do it, and just touch it. That quick, your joint's done. No heat, no nothing. Instantly put your fingers right on your deal. Your solder ball's there, everything. Now it's best to do this every joint, because you get the rosin core to melt, and it cleans your tip and it cleans the pad here. None of that extra rosin or anything like that, or flux or whatever you want to call it. You know, all these old school methods from the 1960s are no longer valid for the electronics we work with today. Now the pads I just did here on this particular flight controller, the DAL F77, these are for the receiver. Next ones I'm going to do are the 3 here for the VTX and the 3 over here for camera. I'm going to be using the connector that came with the pair here. I don't like doing that, but I'll start off like that, and later on, if I find I need to do this super small solder work, I'll do it later, make the build a little neater. But for now, we're going to prep this as though we're using normal wire work. And again, always, never, well, yeah, always, there's a contra. Never tin your tips over your work. Never cut wires and strip wires over your work, as you always will leave 1 or 2 strands flying all over the place. Strip your wires and tin your wires away from your work, especially if you're working inside a frame. I know that's not the easiest thing to do, but if you're careful with all that, you will not leave anything to short your gear out with. Again, I'm working kind of close here because of the camera work, but normally I don't do that. And again, sorry for the not so great lighting conditions here. I'm not set up like all the pros that do their videos and stuff. I'm just some guy building this stuff and yakking away as he does it. Again, I don't know if you can see it, but no big blobs of sticky mess from the flux melting. The joints are nice, super cool. No heat going to the board. Everything is beautiful. I'll try to work from like the inside to the edges if you can. If there's room like this to get straight and go straight across, you can do that. But like here where it's up against this connector, I'm going to start here and work my way back, so I don't have an issue with melting or bridging any connections. You see how that one's stubborn? It doesn't want to do it. It's kind of hard getting the angle here, but and maybe because I didn't have the solder down far enough, or just got the heat temp or the temp just that close to the melting point that it's right there on the borderline where I didn't melt the solder as it was on the pad. And again, time on the pad is bad. No heat, no nothing. And this board is, all those joints can't even really feel the heat. And what little heat is there is already sucked out by your skin, your body temperature equalizing things. Okay, now, for these bigger pads, the temperature I have set is still good enough to do the tinning. Now, when I start putting the thicker wires on there, I may have to crank it up to 4, just to get it, and maybe as high as 5, 5.5 for the heavy power leads. But for now, we'll see. We'll just continue on. Now, the trick with the bigger pads like this is not staying on there longer, is starting with a bigger ball of your tin. So it's just hanging off the tip. And again, always put your solder down here, because that's what's going to transfer the heat fast enough without doing anything to the board. And again, my spastic fingers. But that's it. I mean, right, nothing. Not even warm. So just put a little bigger ball on your iron. Put your solder in there. Boom. Again, right on it. No heat. No heat whatsoever. Now, another thing is, I see all these guys using all these crazy steel wool looking balls and scrunchy things to clean your tips. Simple damp sponge is all you need. And just keep it tinned every, clean it and tin it every joint. And with practice, your work will look beautiful. And again, like I said, save all those little solder balls, put them in a case, and then You can melt them down later for counterweights. You don't have to go pay for lead when you're building your planes. Now this one, you notice how I took a little longer on that one. I think it's because I'm not getting the iron flat enough down in that area. So, now also, a couple of videos said where they heated the pad first and melted the solder, that they had to watch underneath where the solder would pull through. You can see it's barely pulling through here. So you're not overheating it, and you're not letting the solder get so hot that it's totally liquid where it just pours through those tiny holes and causes a blobbing issue. So, you know, it takes a little practice and takes a little bit of persistence to get the habits down. Once you do, your work is going to be a whole lot better. Your gear is going to love you for it, and you'll burn less parts. And again, immediately right after, nothing. I mean, it's a little warm, but nothing to write home about. So, as you see, this is a flight controller and a matching 4-in-1 ESC. I've never worked with the 4-in-1 ESCs, and starting to get more into racing and stuff, and gotta find ways to cut weight down, so you kind of not be able to go with the heavier single ESCs. And I'll do a weight comparison with this and the last copter I built named Taz. Taz will do between 130 and 150 mile an hour, depending on how accurate your timing is. I don't have anything to measure real speed, but we shall see. Hopefully this is coming out a little bit lighter. I know I got the heavier Emax motors, but as I said earlier, I'm not a fan of the open bottom motors. Every time I fly one, I end up having to tear the motor down apart and clean out the dirt, and it's just a real pain in the butt. And especially when the motors that I do have that are open bottom do not have the screws, they have the C-clips underneath them. Those are a nightmare to get apart and put back together just to clean some dirt out of them. So I go with the closed bottom motors. I still get the speed. So what if it's a little bit heavier than anybody else? But it seems to me I like flying with the heavier stuff because it gets around corners better. Okay, now my old eyes, I didn't see if I crossed them or not, so do a quick check. Make sure there's no bridging, which I do have. That last joint there did bridge. So if you bridge like that, dry iron tip, and just pull. Pull the solder away. May have to heat the tip up a little more to do this, so I'm gonna do that off camera. That way we're not sucking up any time. I'm gonna do these quick leads here and move into the next part of this. Again, bigger glob to make it go on there quicker. Again, you're going to run into little mishaps like that, nothing to panic about. Just get used to practicing how to handle them, and what to do. So that's it for the quick prep. That's a little warmer than usual, but nothing to burn your fingers over. Alright, that's it for this part. Next part's going to be connecting all the ESC and motor wires up inside the frame where everything's nice and tight. Alright, as you see, I have got the ESC put into the quad temporarily. I gotta get shorter bolts that are custom fit to the height that I want, but that's no big deal. That can always be done because they go in through the bottom. Now, as you see the work that I've already done, it's almost like custom built headers. I start with if the motor wires were in this way, I line them all up the same. So that way when we switch motors and set up all that stuff in beta flight, they're all the same starting point. It also makes a neater build where you're not having wires crossing and twisting and all kinds of other stuff. So first thing I did to do this is I'll work from the shortest one out to the longest one. Okay, so you find your bend here and make that tighter so it hugs that post. And then I'll take my hemostats and do the bend to start shaping it. Now, keep it pulled back tight here against that post. Not sure if, yeah, it's showing the video. Okay, against that post there, and then I'll take my fingernail and mark where I want to cut the wire. Again, pull it away from my work where I'm not cutting wires over top of any electronics. Same thing with stripping them. Guys, don't do this. Do your thumbnail, pull it off stuff. It makes it raggedy, and you also stretch your heat shrink, so when you heat it up it pulls back and you got more exposed wire than you need to. Basically, I put my finger over the edge here to measure near perfect cut lengths. A little twist. Make sure there's no wires or anything laying here. Keep the wire up out of the way. Tin the wire. Always put your solder on the bottom, your iron on the bottom, and let the solder pull through your wire. That way it gets all the way through into your wires. Twist it back around again. Again, make that bend tight so it stays in place. Take your hemostats or your needle nose, whatever. Get your wire lined up how you want it. Make sure you're in the video if you're doing all this stuff, but anyway, all set. You want your coverings right to the edge of your PC board. And what you're going to do is heat this up, tin your tip, heat the wire, and you'll see it relax into the pad. That way you know you got a good bond. Don't press, don't do nothing, just set your heat on there. And you feel it relax into the pad. Don't blow on it, don't move it. And there you have it. Nice beautiful joint. You can still see the wire windings here where you twisted it for your tinning. So it lets you know you got a good bond but not too much solder. And then we go to the middle wire. Again, make your hard bend. Take your hemostats. Get Put your wire where you want it to be. Helps if your fingers work. Mine don't seem to want to be behaving today. It's taking a little extra time. Again, mark where you want to cut your wire. Pull it away from your work. Cut it. Again, put your finger over the edge of your strippers. Put your wire in until you feel it. That's usually the perfect spot. A little pull. Again, twist. Keep them all nice and tight. No little strands laying around. Turn your tip away from your work. And pull the solder through. Easy peasy. It's all simple. Just time and patience. Again, redo your bend if it's straightened out. Keep that tight up against the post. That way it doesn't interfere with the flight controller and the soft mountings. Do your bend. Another nice thing about doing this with hemostats is A, they're small, and B, they also act as a heat sink, so the heat doesn't wick up through your wire and mess with your coatings, your coverings. Tin your tip. Set it on there lightly. Let it sink in. Let it cool. And you're done. And finally, your last one. Again, get your tighter bend so the form fits better. Your hemostats to hold it in place. Get your measurement. Pull it away. Cut it. Strip it. Almost forgot to tin it. Very important step. Now this one looks like I stripped it a little bit long, so after I tin it, I'm going to snip the wee bittest part off it, so it's not sticking way out. Again, put your fingers over the edge of your stuff. Don't pinch your fingers in there, but catch that little piece so it doesn't fly around. Drop that in your sponge tray so you can save it for weight later. And again, put your wire in place. Tin your iron. And voila. Now, after you're done, always take a magnifying glass and inspect your work. Not sure how good this is going to come out on the camera, but make sure there's no bridges, no little solder balls and all that. I'm going to finish this segment here and go edit this video, and we'll move on to the next parts.